This video is about even and odd functions. Even functions are symmetric to the y-axis. Remember that this is the y-axis. Y-axis. They are symmetric to the y-axis. Even functions symmetric to the even axis. Odd functions are symmetric to the origin. This is the origin. 0, 0, right? Even functions are symmetric to the y-axis. Symmetric means they are equal on both sides to the y-axis. Here's a test to test for even functions. You plug in a negative x. You plug a negative x in. What this notation means is you get out what you started with. You get out the function. F of x is just the function. So you plug in a negative x for all the x's. The result will be what you started with. So you plug in negative x, you get out what you started with, or the function that you started with. That is the test to see if something is even. So here's an example. F of x equals x squared. So if I plug a negative x in, when you do negative x times negative x, you get positive x squared. You get what you started with. See, here's where I started. And when I plug a negative x in, I get back what I started with. Here's another example, the absolute value. If you plug in a negative x for absolute value, you get out a positive x, or you get out what you started with. Absolute values are v's. That's a shape, and they are symmetric to the y-axis. This is the y-axis. All right, here's another one. Example 3. F of x is x squared plus 4. So this graph looks like this right here. You take a parabola and you move it up 4. And if you fold it over the y-axis, it is symmetric. Here's the test. You plug in a negative x, you square it, you get what you started with. Do you see that this function is the same as what I started with? So these are all even functions. Here's one more. Even function. Example 4. F of x equals x squared minus 3. So if I plug in a negative x and square it, I get positive x squared minus, and then subtract 3. So this is the same as what I started with. This is what I started with. Right here, this is what I started with. The function I started with. So that's what that weird notation means. It means if you plug in a negative x, when you solve the problem, you get out the function that you started with. Odd. Odd graphs are symmetric to the origin. This is the origin. 0, 0 is the origin. How the test works. You plug in a negative x, you get out the opposite of what you started with. That negative sign means this negative sign right here is the opposite of what I started with. All right, this is x cubed is one of the parent graphs of an odd function. If you plug in a negative x and you solve it, negative times a negative times a negative is still a negative x cubed. So if you compare this to this is what you started with. This is the opposite of what I started with. See, the sign is opposite This is a positive sign, and this one's a negative sign. All right, next example. Example 6. This is what the graph looks like. It's symmetric to the origin. If you rotated it around, it would match right up. So you plug in the test. You plug in a negative x, you solve it. When I do a negative x cubed, I get negative x. When I do a negative times a negative, I get positive. Okay, look at this. This is cool. This is opposite of what I started with. Here's what I started with. Do you see this sign is x cubed minus x? This one's opposite sign. Negative x cubed plus x. This is symmetric to the origin. Example 6. Example 7. Symmetric to the origin again. So odd function. 2x cubed minus 4x. Here's what the graph looks like. If you plug in a negative x, you get negative x cubed times 2. So the negative comes out in front. If you have a negative 4 and you times it by a negative, you get positive. Here's what you started with. Here's opposite, exactly opposite. See, this is a 2x cubed. This is a negative 2x cubed. See, this is a negative 4x. This is a plus 4x. Opposite signs as the start. So this is odd. Odd. Okay, this is really how most of them turn out. So here's a function, f of x equals x squared minus 3x plus 4. So if I plug a negative x in to test it out, this is how you test it. You plug a negative x in and you solve it. Negative x gives me positive, and negative 3 times a negative x gives me positive 3x, and a 4. So if you compare this, answer to the original, it's not exactly the same as how we started. So it's not even, and it's not everything opposite. So it's not odd. So this you call neither. All right, that's it.